Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on linear algebra chapter minimal polynomial and minimal equation of a matrix, lecture number 4, in which I will prove some more theorems of this chapter. Now we prove a theorem. Theorem is every root of a characteristic equation of a matrix is also a root of the minimal equation. Now we prove this. Let mx be the minimal polynomial of a n-row square matrix A. Therefore, MA equal to 0 matrix, because minimal equation of a matrix annihilates the matrix. Means in place of x, if we write matrix A, then we get 0 matrix. Let this is number 1, minimal equation of the matrix A is mx equal to 0. This is number 2. Let lambda is a characteristic root of matrix A and mx being a polynomial, we get that m lambda will be the characteristic root of MA. This is matrix polynomial and this is polynomial in the variable lambda. Using 1, we get m lambda is the characteristic root of MA equal to 0 matrix. That is, m lambda is a characteristic root of a 0 matrix. We know that characteristic root of a 0 matrix be 0. Therefore, m lambda equal to 0. This is number 3. From 2 and 3, we get that here in place of x we have lambda. That means lambda is a root of mx. That is, lambda is a root of minimal equation of a matrix A. Therefore, every root, since lambda is characteristic root of the matrix A, therefore every root of a characteristic equation of a matrix is also a root of minimal equation of the matrix. Proved. Now we have a note. Since from corollary 2 we have seen that every root of the minimal equation of a matrix is also a characteristic root of the matrix, and from this theorem every root of a characteristic equation of a matrix is also a root of the minimal equation. Converse. This is the converse of this and this is converse of this. Then we may conclude that lambda is a characteristic root of a matrix if and only if it is a root of the minimal equation of that matrix. Therefore, if fx is the characteristic polynomial of a matrix A and mx is the minimal polynomial of matrix A, then both fx and mx have same roots, though they may occur in greater multiplicity in fx. Roots of characteristic equation and minimal equation be same. It may be possible that the degree of the minimal equation be less than the degree of the characteristic equation. But roots of both equations be same. Since if n be the degree of an equation, then number of roots be n. Therefore, if the degree of the characteristic equation is greater, then number of roots will be greater than the number of roots of minimal equation. Number of roots may be greater. Number of roots will be greater by repeating some roots. So, in a minimal equation, roots are distinct. Among these distinct roots, some roots repeat in characteristic equation in order to make the number of roots equal to the number of degrees of the characteristic equation. On the basis of these ideas, we define number 1, derogatory matrix. An n-rowed square matrix is said to be derogatory if degree of its minimal equation is less than n. And number 2, non-derogatory matrix. An n-row square matrix is said to be non-derogatory if the degree of the minimal equation is equal to n. Now we prove the next theorem. Next theorem is, if roots of the characteristic equation of a matrix are all distinct, then matrix is non-derogatory. Non-derogatory means if the given square matrix be of order n and degree of the minimal equation is n, then the given matrix is non-derogatory. Let Mx be the minimal polynomial of a n-rowed square matrix A. Therefore, minimal equation of matrix A will be mx equal to 0. This is number 1. Let fx be the characteristic polynomial of matrix A. Therefore, characteristic equation will be fx equal to 0. This is number 2. Since the matrix is of size n by n, therefore degree of fx will be n. Hence, number of roots of equation 2 will be n, given that n roots of equation 2 are all distinct. We know that if lambda is a characteristic root of a matrix, then it is a root of minimal equation. Therefore, the minimal equation mx equal to 0 has n number of distinct roots. Therefore, degree of the minimal equation of the matrix A is n. We know that if degree of the minimal equation of a matrix is equal to n, as A be the n row square matrix, then the matrix is non-derogatory. Therefore, the matrix A is non-derogatory. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button. And if you have not yet subscribed my YouTube channel, then please subscribe my YouTube channel. Thank you.